Welcome to Navy Builder Knowledge. This video is on roof framing and roof construction. Many of the items we cover will be on your advancement exam. We know everyone learns differently. So take notes or replay until you remember. So if you're ready, let's get started. Roof framing terms. We will start with the common roof types. A shed or lean-to may have any angle or slope. Its rafters extend from top plate to top plate. The gable has a ridge at the center and slopes in two directions. The hip has all four sides slope toward the center of the ridge. An intersecting is a combination of two or more roofs joining together. Rafter layout terms. The span is the horizontal distance between the outside top plates of a wall. The total run is half the distance of the span. The total rise is the vertical distance covered by the line. Length of the rafter. The line length is the hypotenuse of a triangle with total rise as altitude. The pitch is the ratio of the total rise of the roof to the total width of the building span and is expressed as a fraction. The unit of run is always 12 inches for the common rafter. The unit of span is always twice the unit of run, or 24 inches. The unit of rise changes depending on the pitch or slope of the roof. The unit of rise is the distance the rafter rises per foot unit of run. The bridge measure is the hypotenuse of a triangle with the unit of run as the base and the unit of rise as the altitude. Now let's cover the gable roof framing members. The ridgeboard is the highest point of the roof where the roof slopes meet. It is a horizontal board or plank placed at the ridge of a roof to which the upper ends of the rafters are nailed. Rafters. The common rafter extends from the plate to the ridge at right angles to both. It supports the main body of the roof and is usually spaced 16 to 48 inches apart. The barge rafter is the same as a common rafter except that it has no bird's mouth and is found on the overhang at the rake of a gable roof. Collar ties are typically 1x6 material that is placed on rafters only to aid in compression or tension of the roof. Gable end studs are upright framing members that provide a nailing surface for siding and sheathing at the gable ends of the roof. Hip and valley roof framing members. The ridgeboard is the same as in a gable roof. Common rafters are the same as in a gable roof. And collar ties are the same. What is not the same? Hip rafters, they extend diagonally from the outside corner formed by perpendicular top plates to the ridge board. Hip jack rafters, their lower ends rest on the top plate, and the upper ends rest against the hip rafters. Valley jack rafters, their lower ends rest against the valley rafters, and the upper ends rest against the ridge board. Cripple jack rafters are nailed between hip and valley rafters and do not touch the ridge or top plate. King common rafters, they extend from the ends of the ridge board to the top plate. Side king common rafters extend from the ends of the ridge board at a 90-degree angle. Roof framing truss types. A truss is an engineered combination of structural members arranged and fastened in triangular units to form a rigid framework for support of loads. King post, commonly used for gable roofs. Queen post is commonly used for gable roofs. Room in attic provides additional open space. Piggyback is used if total truss height exceeds acceptable height for transportation. Vault is used for vaulted ceilings. W-type is commonly used for gable roofs. K-type is commonly used for gable roofs with spans of 24 to 36 feet. Hip is a major truss in Dutch hip system at sloping ends of hip roof. Scissors is used for vaulted or cathedral ceilings. Gable is a non-structural member placed at gable ends to provide nailing surface for sheathing. Now let's cover roof truss construction procedures. The truss design deals with tension and compression. The top chords have a compression force, while the bottom chord has a pulling apart or tension force. The long webs support the bottom chord, placing a tension force on the long webs. The short webs support the weight of the top chords, placing a compression force on the short webs. The construction of the truss places the entire load of the roof, and any load applied to the roof, such as snow weight or wind loads, to the outside walls. Due to the tendency of the bottom chord to sag at the center, the bottom chord is usually constructed with an upward curvature called camber. Fabrication and assembly. Roof trusses are typically ordered from a truss manufacturer and delivered to the job site. Trusses are assembled on large tables or flat surfaces. Truss components are pre-cut, laid out on the assembly table, and secured in position. Metal or wood plate connectors are then properly positioned and pressed or secured into the truss cords and web members. Others are assembled with split ring connectors which prevent any movement of the members. Layout for a W-type truss. The W-type truss demonstrates key contact points of the webs and cords to properly distribute the forces acting on the truss. Also shown are gusset cutout sizes and nailing patterns for nail gluing. The span of the truss, depicted in the slide, is 26 feet and roof cut is 4/12. When spaced 24 inches apart and made of good quality 2 by 4 inch members, the trusses should be able to support a total load of 40 pounds per square foot. Gussets for lightwood trusses are cut from 3/8 or 1/2 inch standard plywood, with an exterior glue line, or from sheathing grade exterior plywood. Glue is spread on the clean surfaces of the gussets and truss members. Staples are then used to supply pressure until the glue is set. Resorcinol glue is normally used in high temperature and humidity attic conditions. KCN or similar glue is used in areas of low humidity. 2 rows of 4D nails are used for either 3/8 or 1/2 inch thick gusset. Nails are spaced so that they are 3 inches apart and 3/4 inches from the edges of the truss members. Gussets are nail glued to both sides of the truss. Plywood gusset, hinge post trusses are limited to spans of 26 feet or less, if spaced 24 inches apart, and fabricated with 2 by 4 inch members and a 4/12 roof cut. The spans are somewhat less than allowed for W trusses having the same sized members. The shorter span for king post truss is due in part to the unsupported upper chord. On the other hand, because it has more members than the king post truss, and distances between connections are shorter, the W truss can span up to 32 feet without intermediate support, and its members can be made of lower grade lumber. Rafter length calculation methods. There are 4 different ways or procedures for calculating common rafter length. The framing square rafter table, the book of rafters, the mathematical method, and the step-off method. We will also cover the shortening of rafters, adding the tail length, and calculating hip rafter lengths. We will start with the framing square rafter table, commonly called bridge measurements. Framing squares have a table on the face side of the blade that can be used to calculate rafter length for pitched roofs with 2 to 18-inch unit rises. For example, for a roof with a 7-inch unit rise and a 16-foot total span. Since the roof has a 7-inch unit rise, locate the number 7 at the top of the square. Directly below the number 7 is the number 13.89. This number is the rafter length per foot of run, also called the bridge measure. Multiply the bridge measure by the total run, which is 1/2 of the total span, or 8 feet. 13.89 inches times 8 feet equals 111.12 inches. Now convert the decimal inch portion to fractional inches by multiplying it by 16. 0.12 times 16 is equal to 1.92 or 1/8. Determine the total common rafter length by combining the results of previous two steps. 111 inches plus 1/8 inch equals 111 and 1/8 inches. Divide the whole number by 12 to convert to feet and inches and add the fraction. 111 divided by 12 is equal to 9 feet 3 inches plus 1/8 inches. Equals 9 feet 3 and 1/8 inches. Using a book of rafter tables. A book of rafter tables contains rafter measurements for a broader range of roof spans and unit rises than does the framing square table. Simply look up your span or total run and it will give you your bridge measurement. Then calculate rafter length using the method in the previous example. Using the mathematical method, no tables or square, first determine the bridge measurement, inches per foot of run, using the Pythagorean theorem. For example, find common rafter length for a building, with a 5-inch unit rise, 25-foot span, and a 13-inch projection. The Pythagorean theorem states, a squared plus b squared equals c squared. C squared equals 12 squared plus 5 squared. You may be a bit confused, so let's break it down. We have a 5-inch unit of rise for every foot or 12 inches. We want to find out the bridge measurement, which is also the hypotenuse of the triangle. So we will take the 5-inch rise and times it by itself. 5 times 5 is equal to 25. We do the same for the unit of run. 12 times 12 is equal to 144. We then add them together. 25 plus 144 is equal to 169. Now we have our theorem. A squared is 25, plus b squared, which is 144, equals c squared, which is 169. Then find the square root of 169, which is 13. 13 is our bridge measurement. After finding the inches per foot of run, calculate rafter length. Determine the roof span. A roof with a 25-foot span has a run of 12 feet, 6 inches. Convert the inch portion to decimal feet by dividing by 12. 0.5 divided by 12 is equal to 6 inches, for a total run of 12.5 feet. Multiply the bridge measurement, 13 inches, by the total run of 12.5 feet, equals 162.5 inches. Convert the decimal inch portion of the previous calculation to fractional inches by multiplying it by 16. 0.5 times 16 is equal to 8 or 8/16 inches, or half an inch. Determine the total common rafter length by combining the results and convert the results to feet and inches. 162.5 inches. Divide the whole number, 162 inches, by 12 to convert to feet and inches and add the fraction, half an inch. 162 divided by 12 is equal to 13 feet 6 inches, plus 1/2 in, equals 13 feet 6.5 inches. The final step is to add the tail length for a complete rafter length calculation. In this case, for a projection of 13 inches, the total common rafter length is 14 feet 8.5 inches. Using the step-off method. In this example, we will use a building with a unit run of 5 feet 9 inches and an 8-inch unit rise. Set square gauges at 8 inches on the unit rise scale and 12 inches on the unit run scale. Place the square on one end of the rafter. Mark the ridge plumb line along the square tongue and draw a line at the 12-inch point of the blade, with the gauges pressed lightly against the rafter. Slide the square to the left. Align the tongue with the 12-inch mark and make a second 12-inch mark along the bottom of the blade. Repeat the previous step 5 times. This will give the rafter length for a total run of 5 feet 0 inches. To add the 9-inch remainder of the total run, place the tongue on the last 12-inch mark and draw another mark at 9 inches on the blade. This will be the total length of the rafter. Shortening common rafters. The rafter length, found by any of the methods previously discussed, is from the heel plumb cut line to the center of the ridge. It is also known as the theoretical length of the rafter. Since there is a ridgeboard between the rafters, 1/2 of the thickness of the ridgeboard must be deducted from each rafter. This deduction is called shortening the rafter. The distance from the heel plumb line to the shortened ridge plumb line is the actual length of the rafter. Adding the tail length. The line length of a common rafter ends at the heel of the bird's mouth, the cut that rests on the top plate. The line length of the tail extends from the heel cut of the bird's mouth to the overhang cut. To calculate the tail length, you take the bridge measure in inches and times that by the projection in feet. Remember, the length of the projection is found on the construction drawings. In this example, with a bridge measure of 13.89 inches and a projection of 18 inches, you will first convert projection from inches to feet by dividing by 12. 18 divided by 12 is equal to 1.5 feet. Multiply the bridge measure in inches by the projection in feet to get the tail length in inches. 13.89 times 1.5 is equal to 20.84 inches. Now convert the tail length to feet and inches. Your math is this. 20.84 divided by 12 is equal to 1.74 feet. 0.74 times 12 is equal to 8.88 inches. 0.88 times 16 equals or 14.08, or 14/16, equals 7/8 of an inch. Ending with a tail length equals 1 foot 8 and 7/8 inches. Add tail length to rafter length. 9 feet 3 inches plus 1 foot 8 7/8 inches equals 11 feet 7/8 total rafter length. Calculating hip rafter lengths with a framing square rafter table. Same procedure as for common rafters, except that the second line is used rather than the first. The second line of the framing square table shows the length of hip or valley per foot run. Remember, when figuring mathematically, use 16.97, which is the diagonal of a 12-inch square. For example, a roof with a 6-inch per unit rise and a 28-foot total span. Divide the total span by 2 to find the total run. 28 feet divided by 2 is equal to 14 feet total run. Look below the number 6 at the top of the framing square. The second line gives 18 inches as the length of hip or valley run. Multiply the length of hip per foot run by the total run. 18 inches by 14 feet equals 252 inches, or 21 feet 0 inches. Procedures for drawing a roof framing plan. A roof rafter framing plan indicates ridgeboard and rafter size, spacing, roof slope and direction, and all details. It's used to determine sizes and quantities of all components for estimating purposes, and to allow the mass production of all required roof frame components. The estimator may use the same procedures for drawing the roof framing plan to assist in making calculations. This is accomplished by tracing each component type with a different colored highlighter or marker as they tabulate required numbers and dimensions for each component. Procedures for your sketch building outline. You must know the shape and dimensions of your building to be able to make a scaled drawing of the building. For your drawing, you will start with the front of the building at the bottom of the sheet. You will use the scale 1/4 inch equals 1 foot. Darken outline of building. Draw hip roof lines. Locate and draw center lines. Locate intersecting points for hip lines. Run lines from outside corners of building to center lines. Draw valley roof lines. Locate points equal to the length of wings on the center lines on the wings from where the hip lines intersect the center line. Run a line from the inner corners of the building to the center line. Draw cripple hip roof lines, if applicable. Run a line from the intersecting point of hip and ridge on the main building to the point of intersecting the valley and ridge on the wings. Darken outline of ridge, hip, valley, and cripple lines. Draw common rafters, hip jacks, valley jacks, and cripple lines. Darken all rafter lines. Designate corners of building alphabetically, start at any corner, and work clockwise. Roof sheathing types. Plywood offers design flexibility, construction ease, economy, and durability. Oriented strand board, OSB. Wood strands bonded together with phenolic resin, place stamped face. Down with the rough side facing up. Composite sheathing. Veneer faces bonded to a wood fiber core such as OSB. Structural insulated panels, SIPs, have a thick layer of rigid foam insulation pressed between two panels of plywood or OSB, usually used for exposed beam roofs, but can be used for other type roofs. Spaced board sheathing. 1 inch by 4 inch or 1 inch by 6 inch softwood boards, generally used on wood shingle and tile roofs. Roof frame and sheathing material estimating process. Rafters. The size and material depends on the span of the building. The number of rafters depends on rafter spacing. For 16 inches on center, 0.75 times building length plus 1 times 2 sides. For example, a 40-foot building with 16-inch on center spacing, your math is 0.75 times 40 plus 1 is equal to 31, times 2 is equal to 62 rafters needed. For 24 inches on center, 0.5 times wall length plus 1 times 2 sides. For example, a 40-foot building with 24-inch on center spacing, your math is 0.5 times 40 plus 1 is equal to 21, times 2, equals 42 rafters needed. Ridgeboard. Needs to be wider than rafters, 2 inch by 8 inch ridgeboard for 2 inch by 6 inch rafters. For a gable roof, the length of the ridgeboard equals the length of the building plus overhangs at the gable end times 2. For example, a 40-foot building with 10-inch overhangs, 40 feet times 12 equals 480 inches. 480 inches plus 20 inches equals 500 inches. 500 inches divided by 12 equals 41.67 feet. Collar ties. The number of collar ties required depends on local codes. If a city requires collar ties every 48 inches, a building in that city with 21 rafters would require 10 collar ties. For example, collar ties required every 48 inches. With 24 inches on center rafter spacing, a collar tie is required for every other rafter. 21 rafters divided by 2 equals 10.5 or 10 collar ties, required for code compliance. Sheathing. First find the area, length times width, of one side of the roof. For example, a roof 30 feet long and 20 feet wide. 30 feet times 20 feet equals 600 square feet. Multiply by 2 to find the total area of the roof. For example, 600 square feet times 2 is equal to 1,200 square feet total area. Now divide by 32 to find the number of 4-foot by 8-foot sheets of sheathing material required. For example, 200 divided by 32 is equal to 37.5 sheets of sheathing material. Estimate roof framing and sheathing material quantities. Required. Rafter and collar tie layout and installation procedures. Layout and install roof rafters. Perform with a framing square or a speed square. Mark the ridge plumb line. Place a framing square at one end of the rafter. Mark a line along the tongue, unit rise side of the square. This is the ridge plumb line. If using a speed square, place the pivot point along the edge and rotate the square until the rise of the common top cut aligns with the rafter edge. Mark the ridge plumb cut line. Shorten the rafter by 1/2 the thickness of the ridgeboard. Measure at a right angle to the ridge plumb line. Draw the ridge plumb cut line. Mark the heel plumb cut line. Measure the total length of the rafter from the ridge plumb line and make a mark. Place the tongue of the square along this mark and draw the heel plumb cut line. Mark the seat cut line. Slide the square to the left and draw a line along the edge of the blade. This line is the seat cut line. Reminder, the seat cut should not be deeper than 1/3 the length of the plumb cut. In addition, the amount of stock remaining above the seat cut is referred to as the stand or height above plate, HAP, and it is added to the total rise. The length of the seat cut equals the width of the top plate. Measure and mark for the length of overhang. Slide the square to the right so one side lines up with the heel plumb line. Measure and mark the distance of overhang. Be sure to use figures on the same side of the square. Mark the tail cut line. Slide the square to the right. Place the tongue next to the overhang mark and draw a line along the edge of the tongue. This line is the tail cut line. Reminder, tails are normally left to run wild and may be cut later. Once one pair of rafters fit correctly, they can be used as templates for the remaining rafters. Layout and install collar ties. One method of strengthening a roof is to install collar ties at every second or third pair of rafters. Collar ties should be installed in the upper third area of the attic space and are fastened at each end with 4 8D common nails. Divide the amount of drop of the tie in inches by the unit of rise of the common rafter. Double the result to get the collar tie length in feet. Your math is this. Take the drop in inches times 2 and divide it by unit of rise equals length of collar tie in feet. Use a framing square with the unit of run and unit of rise of the common rafter to mark the collar tie to fit the slope of the roof. Intersecting roof layout and framing installation procedures. Layout hip rafters. Square a line back from the end of the rafter stock and mark the center point. Mark the angles for side cuts, ensure the angles intersect the square and center point lines. Draw the ridge plumb line using the unit rise on the square tongue and number 17 unit rise on the square blade. For a speed square, place the pivot point along the rafter edge and rotate it until the desired unit rise and the hip valve scale align with the rafter edge. Shorten the hip rafter by measuring back 1/2 of the diagonal thickness of the ridgeboard at a right angle to the first ridge plumb cut line and make a mark for the plumb cut line. Draw the ridge plumb cut line. Draw the second set of side cut lines. Lay out the length of the rafter along the edge, measure from the original squared line. Draw the heel plumb line down from the rafter length mark, lay out the seat cut line. Draw the seat cut line, measure the overhang and mark the first tail plumb line, square a line across the top of the rafter. Lay out the center point, draw the tail plumb lines and second set of tail cut lines. Find the run of the hip rafter overhang. Hip rafter overhang equals 1.42 inches per inch of common rafter run. For example, a roof with a common rafter run of 10 inches. 1.42 inches times 10 inches equals 14.2 inches, or 14 1/8 inches. Drop hip rafters. Mark the first seat cut line on a piece of rafter material. Measure back 1/2 the thickness of the hip rafter on the seat cut line. Measure at a right angle from this point to the edge of the rafter. This will give the amount of the hip rafter drop. From a laid-out hip rafter, measure the amount of drop from the first seat cut line and mark the new dropped seat cut line. Calculate hip jack rafter lengths from the common rafters. To find the length of the shortest hip jack rafter pair, subtract the common length difference, found in line 4, on the square frame rafter table, from the common rafter length. To find the length of the next shortest hip jack rafter pair, subtract the common length difference from the A hip jack rafter pair. To find the length of the remaining hip jack rafters, continue to subtract the common length difference from the preceding pair of hip jack rafters. Lay out the hip jack rafters. Square a line across the top edge of the rafter, lay out the center point. Using a framing square, lay out the angle for the side cut line on the top edge of the rafter. If using a speed square, place the pivot point along the edge, and pivot along the edge until the unit rise of the common scale aligns with the rafter edge. Using the framing square, mark the top plumb line on the side of the rafter. Shorten the hip jack rafter by 1/2 the diagonal thickness of the hip rafter, draw a ridge plumb cut line on the side of the rafter. Measure the length of the hip jack rafter from the squared line on the top edge. Draw the heel plumb cut line, and lay out the bird's mouth by marking the seat cut line. Measure the length of the rafter overhang from the heel plumb cut line, and mark the tail plumb cut line. Calculate the theoretical ridgeboard length. Calculate the actual length of the ridgeboard. When common rafters are placed at the ends of the ridgeboard, increase the theoretical length of the ridgeboard at each end by 1/2 the thickness of the common rafters. When no common rafters are placed at the ends of the ridgeboard, the theoretical length of the ridgeboard must be increased at each end by 1/2 the 45-degree thickness of the hip rafter plus 1/2 the thickness of the ridgeboard. Assemble the roof frame. Install common rafters at two ends of the ridgeboard. Install hip rafters at the corners. Install the hip jack rafters and remaining common rafters. We hope you have gained some knowledge. While watching this video, these items will be on your advancement exam. Please be sure to subscribe so you won't miss any future videos. Have a great builder day.